There is a large cloud offering based on old CAD, PDM, and PLM systems. Can a good traditional solution also be a good cloud solution? When legacy architecture is brought to the cloud, only the legacy monoliths are virtualized. If you're a vendor developing new software natively using cloud tools, you'll need to invest heavily. You can only reuse a small portion of your very old code. Only if you use a cloud-native solution instead of a cloud-enabled solution will you as a user experience all the advantages of cloud architecture without restrictions. Cloud-native applications are scalable, more resilient, and more secure than traditional ones. Technologies such as containers and microservices are used, which enable applications to be divided into independent and loosely coupled components. These components can then be more easily managed, updated, and scaled without impacting the entire application. Cloud-native software can better handle failures by healing itself or jumping onto another resource. Every process has running one in the background. It takes over in the case of failure. To the user, it seems that the software never crashes. That is not completely correct. He just doesn't notice the problem, loses maximum the last record sent, and therefore doesn't suffer from data loss. Cloud-native solutions have better parachutes. Another feature is that the basis is a multi-tenant database. This means that the cloud service provider can provide its service to many companies at the same time via one cloud instance. He only has to manage one instance and not many. The effort and costs are therefore significantly lower. The multi-tenant data scheme, another indication of cloud native. Having real-time access and working in parallel on the same database object, the 3D model, the BOM, and so on, is more powerful than passing on tasks sequentially. A contemporary foundation has great advantages. Modern architecture makes it easier to create out-of-the-box and easily customizable solutions. A modern cloud architecture frees me from the prison of operating systems, service packs, hardware limitations, and, in the case of CAD and FEA, the provision of enormous local computing power. It is easier for providers and users to keep the software up to date and modern. A good cloud-native application updates in the background while you work. There is no downtime. An update is no longer a nightmare. Everyone always uses the same compatible latest version. The cloud-native architecture makes it easy to scale computing capacity. As more users request more services and computing power, servers are added. A traditional monolith cannot scale like that. This scaling is more cost-effective than constantly maintaining high computing power. The advantage for the user is higher performance and high computing power when it is needed. Servers from reliable cloud providers are more secure than on-premise servers. In a purely cloud-native environment, only commands are sent back and forth. Nothing is saved locally. With Onshape CAD, all geometry and metadata are in the database. There are no files. The intellectual property never leaves the Fort Knox of the multi-tenant database. It is easy for a cloud provider to analyze errors. No crash logs or data files need to be sent. Thanks to the ability to directly access the central database, the service is an integral part of the cloud application. The single source of truth promotes agile collaboration between teams and suppliers. The database makes it possible. Simple, rights-based sharing of a link to an object is more powerful and easier than working in the classic, complicated PDM or PLM prison. This has been around in software development for a long time. Several people work parallel in branches. The best results are unified in the main branch at the push of a button. What works with GitHub is also possible in mechanical design. All of this can only be achieved with a cloud-native architecture on a modern foundation. You cannot build a skyscraper on the foundation of a doghouse.